And hello again, Precalculus students. So this is example number 2. So what I've drawn on the board here is a rectangle. I've let the length be x and the width be y. This is a rectangular garden, and this garden that we're looking for is going to have a perimeter of 100 feet. So when you add all the sides together, you're going to get 100 feet. When you multiply length by width, which is area, you're going to get 300 square feet. So we're looking for the values of x and y that make that happen. So again, this is going to be another substitution problem. So we're going to set up 2 equations. The perimeter equation, so remember, perimeter is sides added together. So you could say that 2x's plus 2y's should equal 100. And for the area is length times width. So the area is going to be x times y is equal to 300. So the difference between this problem and the last problem is that in the last problem, both equations were linear. In this problem, only this equation is linear. This is not a linear equation because it's not a y equals mx plus b. It's not an ax plus by equals c. All right, so what we're going to do is we're going to solve this equation for either x or y. Let's just have you wanted to isolate the y. So you can subtract 2x from both sides to give you 2y's are equal to 100 minus 2x's. Divide everything by 2, and you've isolated y. Y is going to be equal to 50 minus x. So that's y. And remember, this is substitution. So we're going to take this value of y, and we're going to substitute this value of y into here. So what we're going to get is x, this x, times the substituted value for y. So x times y, this used to be the y, is equal to 300. And when you distribute and subtract 300 from both sides, you get a quadratic. Yes, we were waiting for that. We knew it would be here sometime. So this is a quadratic. This is an ax squared plus bx plus c. If you write it in standard form, it might be easier to recognize. Negative x squared plus 50x minus 300 is equal to 0. All right, so as it turns out, this quadratic is not a factorable quadratic. So we're going to have to use the quadratic formula to solve this. By the way, this is a really good problem to have a calculator with you because the numbers get a little bit unwieldy. So when you put these numbers in, A is -1, B is 50, and C is -300. When you put these numbers into the quadratic formula, what you get is x equals opposite of b plus or minus square root of, let's see, 50 squared, b squared, minus 4 times -1 times -300 all over 2 times a, which is going to be -2. And when you use your calculator to reduce this, what you end up with is let's see, you get 2 values actually. One x value that you get is 6.97. And because of the plus or minus, you're going to end up with the second x value And that second x value is going to be 43.03. So then once you find these x's, you put them back into here. The easiest place to replace the x here is this equation. So you get a y value up here of 43.03. And down here, you get a y value of 6.97. So you can see these numbers are just reversed. And the units here are, feet. So if you check this on your calculator, 2 times this plus 2 times that, which is perimeter, does equal 100. And when you multiply this times this, you get a number that's really close to 300. It's 299 point something. We did some rounding here, so there's a little bit of discrepancy, but not a lot. All right, that is the problem. Video 3.
So amazing. That was so amazing.